Hi. In this video, we're going to be going over some practice problems that are similar to the ones on the AP Calculus exam AB. The problem is going to probably range from easy to medium, since I'm saving the more difficult problems later on for a different video. If after the video you still actually need more help, I do offer Zoom classes for the AP Calculus exam, so wait till the end of the video and you'll have details on that. With that said, here we go, and let's start solving some problems. All right, so for this function, you have a g of x function equals negative x cubed plus 300x plus 30, and we want to know when this function g of x is increasing. Pause it to solve it yourself, and then unpause it, and here we go. So of course, the first thing you do when you see the word increasing, that should tell you automatically that we want the slope of the function. We want to know when the slope is increasing, or when we want to know when the slope is equal to a positive value. Okay. Before we can do that, we have to find the slope equation. And of course, the slope equation is just the first derivative of the g of x function. So then we have g prime of x is equal to negative 3x, bring the power down, subtract the power by 1, plus the derivative of 300x is just 300. And then the 30 goes away because it's a constant. And now we need to figure out, before we can figure out when it's increasing and decreasing, we need to figure out when it's doing neither, or exactly at 0. So we first set this equation equal to 0. So then we have negative 300x squared equal plus equal to 0. And move the 300. Actually, we'll move this to the other side because it's negative and it's easier. So then we have positive 300x squared is equal to 300. Divide both sides by 3. So then now you have x squared is equal to 100. Take the square root of both sides. Take the square root of both sides, and then you have x is plus or minus 10. So now we have exactly where the slope is 0. So it's neither increasing or decreasing. But then we have to find out where is it increasing and decreasing. So on the number line, we will first find, so we have our negative 10 here, and then we have a positive 10. And then of course we need test points on either side of each of those values. So in between them, I'm going to choose the number 0 to test. On the left side, I'm going to choose the number minus 20. And on the right side, I'm going to choose positive 20. So now let's go back to our derivative equation here. So again, here's our derivative equation, and let's plug these values in. So we're going to do g prime of x, and this time g prime of negative 20 is equal to, this is negative 3 times minus 20 squared plus 300. So we don't actually necessarily do the math, just look at it and see what it's going to turn out. So this becomes 400, because after minus 20 squared is positive 400, but then you have a minus 3 and then a positive, sorry, because it's squared, positive 400. So this is a really big negative number. So this is actually negative. So the slope here is negative. And that's not what we want. We want increasing. So then let's check in between the 0. So do g prime of 0 is equal to, so this is negative 3 times 0 squared plus 300. And we see that equals positive 300. So this is actually where it is increasing. So in between here, so increasing between here to here. So the answer then is from negative 10 to positive 10. All right, for this question, it's just giving you a function y is x squared sine x, and it just wants you to find y prime, or y prime, same thing dy dx. So then as you see, we have the variable in 2 spots. We have it here and here. So then we know that's the product rule. And again, the product rule says y prime is equal to, we take the derivative of the first thing. So in this case, the derivative of x squared, which is 2x. We leave the second thing alone. So then this becomes 2x times sine of x. And then we add to that, plus you leave the first thing alone. So in this case is x squared. And then you take the derivative of the second. And so in this case, the derivative of sine is cosine of x. And that is your solution. All right, for this function, you have g of x is equal to 2 ln x plus 5x minus 17. And we want g prime of 1. So then we just take the derivative of g of x, which gives you, so g prime of x, the first derivative. So 2 ln x, we just, that is just, the 2 stays constant, so ignore that in the front. And the derivative of ln x is 1 over x times the derivative, but in this case, the derivative of x is just 1. Plus the derivative of 5x is just 5. And the derivative of minus 17 is a constant, is just gone. So that is our derivative equation. And now they want us to plug in 1 into that equation. So then g prime of 1 is equal to what? So then we have 2 times 1 over, and they want 1 down here, plus 5. So then it's equal to 2 plus 5, which is equal to 7. For this problem, it's a pretty straightforward integration. Hopefully you remember what the relationship between the secant squared and its derivative function. So if you don't remember, the identity is that tangent x, the derivative, when you take the derivative of tangent dx, that gives you secant squared x dx. Therefore, the integral of secant squared x dx in this case just becomes tangent of x, and then don't forget, after that, plus c. All right, for this problem, we're given a graph, and we have to figure out between the points x of 1, 2, and 5, the points down here, which one of those things match the criteria of A, B, and C. So let's go for A. Between 1, 2, and 5, which one of them has no limit? So we can see that from 1, when you approach 1 from the left, approaches 2, 1 from the right also approach 2. So 1 has a limit. Let's try 5. From 5, it approaches 3 from the right, and then it approaches 3 from the left. So that also check has a limit. But then 2, when we come from the left, we approach number 4. But then when we come from the right, we approach number 8. So 2 does not have a limit. So the one that has no limit is so x equals 2. X equal at x is equal to 2 is where we don't have a limit. All right, and the second question asks us whether or not it has a limit, but it says we can't take the derivative of it. Well, whenever we can't take the derivative of something, it's usually like a sharp turn. If it has a limit, that means it's approaching the same value. So looking at that, that is at x is equal to 5 right here. So they're approaching the same value and it's continuous, but because it's a sharp turn, is not differentiable. So x equals 5, not differentiable. And then which one has a limit? Well, obviously we said earlier, x equals 1 has a limit, and that limit, or the height, when you get close to 1, is equal to 2. So which of the values equal limits? X equals 1 has a limit, and that limit, or that y value, is equal to 2. For this problem, we're giving a y function of sine x plus x squared to the third power, and we want dy dx. And because all of that's to the third power, we know we're going to do the power rule and then the chain rule inside of it. So then, to get dy dx, in this case, it's just a derivative. So dy dx, y dx. So the first thing we need to do is bring that power in front, that 3 down in front of here. So then we have 3, and then of course, chain rule says write exactly everything the way it is. Don't touch anything. 3x plus x squared. And now you subtract the power by 1, and then you also multiply that by the chain rule of the derivative of the inside. So derivative of the inside, the derivative of sine of x is just cosine of x. plus the derivative of x squared is just plus 2x. And then that is your answer. All right, so for this question, we're given the velocity equation is equal to minus 2t squared minus 4t, and we want the total distance. So the first thing we need to figure out, what is the relationship between velocity and distance, or total distance? Okay. And the relationship is, you can say it two ways. You can say velocity is equal to the derivative t of the distance, or you can say the distance is equal to the integral of velocity, depending on what we're given. So in this question, we are given velocity and we want to find distance. So it'd be easiest to use the second one because you are solving for velocity to get you distance. And it says to do that, so to get distance from velocity, you must integrate the equation. So then this becomes the integral of the equation that we're given, which is minus 2t squared minus 4t. Okay. So now and then of course the time was given from 0. We were given from 0 to 2. Okay. So now we just integrate like normal. So this equals, the integral of this is minus 2t to the third power divided by that due power, because you add the power by 1, minus 4 in this case. T was originally this is to the 1 power. So now, because you add 1 to the second power divided by 2. And I clean this up. This equals then minus 2t to the third power divided by 3 equals 4 over 2. That just becomes 2t squared. And we go from the range from 0 to 2. Because both the variables times are in both sections, we don't technically have to worry about plugging the 0 in it because it automatically equals 0. So I just plug 2 in to the equation. So now we're plugging 2 in. So it's going to be equal to minus 2, plug it in the 2 to the third power over 3, and minus 2, plug in the 2 in to the second power, and then it's over nothing. So then we do the math. I'm actually going to pull out the 2 squared because this is technically over 1. So I'm pulling out from the numerator just to make the math a little bit easier. So I'm pulling out the 2 squared out in front. That leaves me in the first one to be minus 2 times the 2 left over, the one of the 2's left over. And then on this one, we have just minus 2 because both those 2's got pulled out in front. 2. And then this one, of course, is over 3. This one's over 1. Now we solve this. This becomes minus 4 over 3 minus 2 over 1. And then we do common denominator. So then this becomes minus 4 over 3 times 6 over 1. Oh, sorry, 6 over 3. Okay, and then we combine them out. It becomes a minus 10 over 3. And don't forget we multiply by the 4 that we pulled out earlier. So the final answer is minus 40 over 3. So for this problem, we have a bathtub that in the beginning has 10 liters of water at t equals 1 hour. And then we add to that at the rate in the table to the left. And they want you to use a Riemann sum to get a total amount of water after 7 hours using a subinterval of 3. Okay. So the key to this problem is recognizing that you have a right Riemann sum. Okay. So the best thing to do to start off this problem is to plot it as best as we can. Okay, so we know that the first one, our one here, this is approximately 2.1. This one's slightly lower, and this is at 3. And this is at 4. And then way over here, that's probably not that big of a drop. Right. Oh, right there. And then that's 7 out here. It's a little bit more drop here. Now we know that the down here is the values x equals 1, 3, 4, and 7. And then we know that the y values here, this is 1.6, this is 1.7, 1.9, and then 2.1. Okay, so basically to get the right Riemann sum, we draw the triangle from the right one onward. So here we can make this make this a horizontal line to this right point right there. And then we do it here. Oh, not like that. That's a trapezoid. And like this. And then like this. Then like this. Okay, so then we have these shapes. We want 3 subintervals from the right hand side. So it would be this one right here, this one right here, and this one right here. Okay, so then we just get the shape. So then we'll call this one rectangle 1, rectangle 2, and rectangle 3. We just get the area of rectangles of each of those rectangles and 5. So for rectangle 1, the width, we can see that from 1 to 3, the width of this is 2. So it's going to be 2 times the height. In this case, the height is 1.9 times 1.9. Okay. And then we multiply it out in a calculator. 2 times 1.9. Actually, should know that 3.8. And then for rectangle 2, we see that it has a width of just 1 from 3 to 4. So from here to here is just 1. So it can be 1 times the height. In this case is 1.7. So now we have 1.7 here. And for the third rectangle, you have from 4 to 7. That's a width of 3. So it's going to be 3 times, and this times the height of 1.6. Okay, so it's going to be equal to 4.8. Okay, and then we just add them all together. So we have 3.8 plus 1.7 plus 4.8. So we had a 10, and add additional, which we're adding an additional 10.3 liters additional. The reason I say that because the bathtub had already 10 liters in here. So then the total amount of liters, we had the 2, which gives you 20.3. All right, so for this problem, we're given g of x, given as sort of like a piecewise function. In the first part, we have the 4x plus 3 times 2x minus 4 over 2x minus 4, and x cannot be 2. And the bottom is whenever it's equal to k for x equals 2. And they want to know is what value can k be so that this function is continuous. So basically, you first have to, you're basically going to set it equal to k whenever you remove the removable asymptote. So then you take the equation g of x, the first part of it anyway. So the 4x plus 3 times 2x minus 4 over 2x minus 4. Get rid of the removable whole. So then you have now, this function is just 2 4x plus 3. And then we want this equal to k. So we're going to set it equal to k. And then, of course, this, when you say equal to k, where x is equal to 2. So then basically you plug in 4 times the 2 plus 3. Okay, and we solve it. This is equal to 8 plus 3, or k is equal to 11. So for this question, we have an f of x equals to an e function, e to the x over 3, and they want to know what is the area between the origin and x is equal to 1. So basically, that is just your standard definite derivative equation where you are going to go from the origin point of 0 to 1. We want to know the area. It doesn't really matter what the graph looks like, because you can just take the integral of it anyway. But just for those who are curious, the e function is going to shape something along this lines here. But regardless, we just need to find the area. You just take the integral of the function. So to get the area, is just going to be equal to the integral, in this case, from the origin 0 to 1. We'll make things better, from 0 to x equal to 1. So yeah, so this is where, so from right here, from 0 to 1, we want this area in here. The function given, which is e to the x over 3 dx, okay? Of course, this is the integral. You can't, if you know it right away, you can go ahead, which you can, solve the integral. But if you forget, you technically make it easier on yourself by doing u substitution. U is equal to x over 3, and then du is equal to 1/3 dx. And now you just substitute out this here and this here in the respective spot in the function. So when you sub it out, we have equal to the integral of e to the u. In this case, we remove the dx by itself. We multiply both sides by 3. So it's going to be 3 du. So the e to u is going to be, now instead of dx, is going to be 3 du. And when we integrate that, this just becomes, take the 3 and the constant in front. So the integral of e to the u is just e to the u. And now, before we put the boundaries, we have to change the u back to x. So now it becomes 3 times e to the x over 3 from the boundary conditions of 0 and 1. And of course, now we just plug it in like all definite integrals. We first plug 1 in, so it becomes 3 e to the 1 over 3 minus 3 e to the 0 over 3. We simplify this. This just becomes 3 e to the 1/3 minus 3 to e to the 0 is just 1. And that is our answer. So for this problem, they give you an integral from 1 to 16 of e to the square root of x over x, and they want you to write the u substitution equivalent. So you're not solving it, you're just doing the u sub and plugging all the values and substituting out the values in. So as you can see, you set the u sub equal to the denominator, or whatever, in this case, the power. So I'm going to set the u is equal to the square root of x. And then, of course, that's the same thing as saying x to the 1/2. And then now, to du, then it's going to equal to 1/2 x to the negative 1/2. And then we'll clean this up. Same thing saying is 1 over 2 square root of x, because the negative power, the 1/2 is the same thing as square root, and the negative power brings it downstairs. Okay, and then this is du, and then this is equal to dx here. And there's a dx up here. Okay. And then now you substituting everything out. So first of all, you want to get the dx by itself. So here, dx is equal to 2 square root of x du. And then this u is pretty straightforward. So now going back to our function, we have instead of square root of x, we're going to say e to the u. And then, of course, the square root of x is still down there because we haven't got anything to substitute out. But dx, in this case, we found the substitution for that, which is 2 square root of x times du. And now from this, we can see that, and of course, the integration sign is still there. But in this case, the square root of x cancels out. Okay. And then now you have the integral of e to the u times 2 du. Of course, we need to change the boundaries because it was originally an x. So that's fairly easy. We go to the equation and just plug it in. So in this case, e is equal to the square root of x. So now our original bottom x was 1. So u square root of 1 is just 1. That's the bottom boundary. And for the top boundary, it's going to u is equal to the square root of 16. So instead of 16, u is equal to 4. So then our new boundary conditions are going to be from 1 to 4. So this is the solution. You can, of course, bring that 2 out in front if you want for cleanness sake, but that's the correct answer. So this problem, we're giving another piecewise function, g of x, and we want the integral function from 1 to 6 to g of x dx. So the trick of this is to break this g of x piecewise to pieces so that we can solve the total range here from 1 to 6. So there's actually 2 ways to do that. Actually, we can do it the traditional integral method, or we can do it the shapes and geometry method. We just do it the graphing method, which I think is quite a little bit easier to see. So I'm going to draw it out here. Okay. So we see that from the first part, from 1 to 3. So here, so from 1 to 3, it is a line starting at, when it's 1, the value here starts at 2, and then it goes to here, that is 3. So this is basically parallelogram from 1 to 3, and when you're at 3, well, 3 actually goes all the way to 4. And actually, we just change this value here. So here, at 3, this is 4. Okay. That, and then when we get to 4, the second part, from 3 till 6. Oh, it becomes basically a square. Okay, so then we just look at the shape. So then we see that the base of this first one is just 2. The base of this one, or the distance from here to here, is just 3. The height of this, or this the rectangle, is just 4. So in the area of this one, it's just 12. And the second area is a parallelogram. So we know that the base of the parallelogram is 2. And then we need to times it by the height, the 2 heights. So it's going to be 2 plus 4 divided by 2. So then that's 2 plus 4 is 6, going to be 2 times 6 over 2, which is just 3. So it's equal to 2 times 3. So this is equal to 6. This here is equal to 6. So the total area is equal to 18. And now the second way to do this is our traditional integral by splitting up the integral into 2. So we're going to split this integral into 2 additive integrals. So the first integral will be from 1 to 3. So this becomes the integral from 1 till 3 of x plus 1 dx. And you add to that the integral, the second part of that, which is 3 to 6 of just 4 dx. Integrating both sides, over here you have then x squared over 2 plus x from 1 till 3, and then add to that, the integral 4 is just 4x. Integral from here is from, from 3 to 6. Okay, you can see from this one, this is quite nicely gets break down easily. So it's going to be 4 times 6 minus 4 times 3, or in this case, 24 minus 12, which is equal to 12. So you can see that the right one matches what we had early here in the shape. So for this one, we're going to do traditional 3 squared divided by 2 plus 3, and then we subtract that. It's going to be subtracted by 1 squared over 2 plus 1. Then we have, in this case, we have 3 squared, 9 over 2 plus 3 minus, this is a 1 over 2 minus 1. So then we know that the 9/2 and the 1/2, that becomes 8 over 2. And then the 3 and the 1, that becomes plus 2. So this becomes 8 divided by 2 is 4 plus 2. This is a 6. And then there we go, the same 6. So this is also equal to 18. For this problem, we're given an f of x function and g of x function, and they want the derivative of f of g of x. So it's pretty much your standard derivative, except you have to do a composite beforehand. So to do a composite, we just put one into the other. So in this case, we want the g function here. We want to put that, the f of x function. So in this case, we would have f of, this case, you want all of this right here, the g of x. So we want to plug that all into the x. So then f of g of x is just equal to 2 times, instead of g, we're going to write what the g function is equal to, which is x squared minus 2. And then don't forget the plus 1 at the end, the f function here. And then now we just take the derivative like normal. So basically, this is just derivative. I'm going to rewrite it actually before we take derivative. Let's rewrite that as x squared minus 2 to the 1/2 power plus 1. And then now let's take the derivative of it. So then f prime of g of x is equal to, leave the 2 alone, bring the power down. So this is going to be 1/2. Leave the inside alone, x squared minus 2. Subtract the power by 1. So 1/2 minus 1. So you have 1/2 minus 1. In this case, it's going to be negative 1/2. Don't forget the chain rule, which I actually did as well. So then we multiply that by the chain rule of x squared minus 2, which is just 2x, and then 2 minus 2 is a constant. And then the derivative of plus 1 is gone. So now we clean this up. So this just becomes x squared minus 2 to the negative 1/2 times 2x. And of course, we don't like the negative power, so the 2x stays up top. And then on the bottom, we have x squared minus 2 to the positive 1/2 power. And of course, you can rewrite the 1/2 power as the square root, so 2x over the square root of x squared minus 2. All right, for this question, we have a particle moves along the y-axis represented by the function y of t is equal to t minus c times t minus d, and then c and d are not equal to each other and are constants. So when the particle is at rest, they want to know what t is equal to. So the key to this question is knowing what happens, or what does it mean that the particle is at rest. So you should realize that when the particle is at rest, this means that velocity is equal to 0. Okay, and then realizing that, you have to remember what the relationship between a position function, which in this case is y and t, and the velocity. Mainly that the velocity is equal to the derivative of the position function. So with that, knowing that, we first need to find the first derivative of our function. So let's take our function and take the first derivative. So here's our function. And let's take the first derivative of that. Now you can do the product rule, or you can fold this out and then take the derivative. I will just fold it out and take the derivative because it makes easier. So then this becomes t squared minus ct minus dt plus cd. Okay, and then now we're going to take the derivative of this function. So y prime of t is equal to, so this becomes the derivative of t squared is just 2 times t minus the derivative of ct is just c by itself. The derivative of dt, which is not the dt you think, is just the letter d and the letter t, which is going to be just d by itself. And then the derivative of a constant goes away. So this is our function. And then we want to know when this function, the velocity, so this is our prime, so this is our velocity function. We want to know when it's equal to 0 or at rest. So then we set this to equal to 0. So we have 0 equal to 2t minus c minus d. Solve for d. So we're going to add c and d to the other side. So you have c plus d is equal to 2t. So the time is going to be equal to divide this side by 2. So the time will be equal to just c plus d divided by 2. All right, so for this question, we're given a graph of a g of x function, and it was told that g of x is equal to the integral of f of x dx, and it wants us to sketch the f of x graph. Okay, the key to understanding this is to first put the relationship of f of x in terms of g of x and not what's given, not the other way around. So basically, we need to figure out to get f of x completely free of that. So we know that, let's rewrite it backwards. So we know that the integral of f of x dx is equal to g of x. So I'm just rewriting what they gave us the other way around. But this is important. Now we need to know that we want the sketch of f of x, not the integral of f of x. So we need to get rid of this integral sign. And to do that, we do the opposite mathematics, which is derivative. So therefore, you take the derivative. So to put d or dx on both sides, the derivative dx on both sides. So then the left-hand side, those two cancel out. So you have now, you free up, you have f of x. So f of x is equal to now just the derivative of g of x. And another way to write that, of course, there's multiple ways, but we also write it as equal to g prime of x, or even you can write it as, actually that's fine for right now. And then now we know that f of x is equal to g prime of x. What's another word for g prime or derivative? Another word for that is the slope of the original function of g of x. So we know that f of x is the slope of g of x. So let's, and the graph that it gave us is g of x. So basically we need to find the slope of this thing, the slope of that is equal to f of x, okay? Looking at this, we see that this graph is going down, so therefore the slope has to be equal to a negative number. And then one other thing that's important is that on a line, just like when you did the slope formula, no matter what 2 points you take out of this line, the slope would always be the same. Therefore, the slope is also constant or the same throughout. So if we were to sketch the actual slope graph, or in this case, f of x, so we were to sketch this graph out here. The slope is a constant value. So this is going to be our f of x. This is going to be our x of x graph, which is our slope graph. So it has to be constant, it has to be negative. So this side here is positive, this side here is negative. So we know we have to draw it down here. And because it's constant, we draw a perfectly horizontal line like so. So this will be the sketch of that graph. All right, so for this problem, we have the limit of ln of 2h plus 5 minus ln of 5 divided by h. So as with most limit of h goes to 0, the first thing we should try is plugging in 0 for h. So in doing that, we have the ln of 2 times 0 plus 5 minus the ln of 5 all over 0. So on the top, you have the ln of, in this case, 2 times 0 is 0 plus 5, so the ln of 5 minus the ln of 5, and all on the bottom you have 0. The top, ln of 5 minus ln of 5 is 0. The bottom, of course, still 0. When you get a 0 over 0, that should automatically trigger you that there's something you should do or could do with this. So in this case, as limit to h equals 0 over 0, 0, you would do the L'Hopital's rule, which just says that you can take the derivative of the numerator completely separate from the derivative of the denominator. So in this case, let's go back to our original function. So it's ln of 2h plus 5 minus ln 5 all over h. So let's take the derivative of the top, completely ignoring the bottom. So we're not doing the quotient rule. That's what low hypothesis allows us to do. So the derivative of the ln 2h plus 5 is equal to 1 over 2h plus 5, and then we have to multiply that by the chain rule of 2h, the derivative of 2h plus 5. So in this case, it's just 2. And in the next one, the derivative of ln 5, that's just a constant, so that goes away. Now we take the derivative of the bottom independently from the top, so the derivative of h is just 1. Cleaning things up, you have 2 over 2h plus 5. And now, when we put in the limit is 0, we put in 0 for h, you have 2 over 2 times 0 plus 5, or in this case, the limit is equal to 2 over 5. All right, so for this problem, we have a function g of x, which is equal to x divided by x plus 2, and it tells us that we have a slope at 1/2 at the point xy. They want to know what are the value of xy. So the key to this problem is to recognize that you need to first find the slope equation of this problem. So, as you should all recall, the slope is equal to the first derivative of the function, or the slope equation. So in this case, if this is our function, to get the first derivative, in this case g prime of x, we're going to have to do the quotient rule. So in this case, the quotient rule says the derivative of top, which is the derivative of x, is just 1, times the bottom left alone, so it's x plus 2. Subtract that, leave the top alone, so this just becomes x times the derivative of the bottom of the derivative of x plus 2 is just, again, 1. And then all of that divided by the denominator squared. Okay, so this is our derivative or slope equation. And we want to know, actually, we'll clean this up first before we move on. So when we clean this up, we get x plus 2 minus x all over x plus 2 squared. And now the x is on top here, cancels out, plus x minus x, leaving you with 2 over x plus 2 squared. Now this equation we said is equal to 1/2 because this is the slope equation, and they said that they gave us a slope of 1/2. So now let's solve this for x. So then we're going to the cross multiply that. So then 2 times 2 on this side is 4, is equal to 1 times x plus 2 is just x plus 2 squared. Now to get rid of the squared, we take the square root of both sides. Square root. Those two crosses out. The square root of 4 is plus or minus 2 is equal to x plus 2. Now you solve this twice because it's plus and minus, so then it's going to be x plus 2 is equal to positive 2, and then x plus 2 is equal to minus 2. So in this case, x is equal to 0, and then x is an equal sign. It's equal to, subtract 2 on the side, minus 4. So these are the two possible x values, but of course you also need the corresponding y values. To do that, you plug into our original equation. So when x is equal to 0, our original equation is equal to x over x plus 2. So let's plug 0 in for x. You have 0 over 0 plus 2. That becomes 0 over 2, which is just equal to 0. So this y value is equal to, which is equal to y. So the first coordinate is 0, 0. First possible values for x and y. Let's do the second one. In this case, we have x is equal to minus 4. And then we plug in minus 4 over minus 4 plus 2. This equals to minus 4 over minus 2, which gives you a positive 2. So the second coordinate is negative 4 for the x, and the y is positive 2. So those are the possible points for this question. So for this question, we're given that f of x is equal to x plus 1 squared, and we're told that g is inverse of f of x, and they want to know what the g prime of 2 is, or the derivative of the g equation with 2 as the x value. So for this, when we see inverse, we actually have to do our old algebra inverse rule. So I'm going to do that by first converting this f of x, just for ease of sake. I'm going to convert f of x into y. So I'm going to rewrite that as y is equal to x plus 1 squared. And then when we do inverse, we are just pretty much swapping. Swap, that's the letters. So we're swapping x and y. So then the inverse function now, with the letter swap, is x is equal to y plus 1 squared. And then again, get y by itself. So we need to get rid of this, the power of 2 by taking the square root of both sides. So square root, the square root of 2 cancels out. So now you have the square root of x is equal to y plus 1. And then now get the y by itself by subtracting 1. So then you have square root of x minus 1 is equal to y. So then g of x, our inverse function, so g of x, and is just equal to the square root of x minus 1. And then now we need to get the g prime at 2. Before we get at the value of 2, let's first get g prime. So take the derivative of this derivative. So then g prime of x. Okay, well then just remember, square root of x is the same thing as saying x to the 1/2 power. So then taking the derivative of that, we bring the power in front. So we have 1/2, leave the x alone, subtract the power by 1. So this becomes negative 1/2. And the derivative of the minus 1 is a constant, so it goes away. So that we're left with this. Let's clean this up a little bit. So get rid of negative power. So that's the same thing as bringing the x downstairs. So this is the same thing as saying 2x to the 1/2 power. And if you want it even cleaner, then take this, the 1/2 to the root side. So this becomes 1/2 times the root of x. And now they want to know at g is equal to 2. So then just plug 2 in. So the answer becomes 1/2 over root 2. So for this problem, we are given 5 different functions, and we want to know which one of those functions has a horizontal asymptote equal to 5. Okay, so try to solve yourself, but pause, but here I will try to solve it. So horizontal asymptote, you can remember from algebra days, has 3 rules basically. So basically, if you have, say for example, x squared over x to the 5th, so the highest power is on the bottom and relative to the top, this horizontal asymptote is equal to 0. If the reverse is true, so for example, you have x to the 5th or x squared, this is infinity or does not have one. And if, however, they're the same, so x to the 5th over x to the 5th, it's just the numbers in front of them. In this case, there's a 1 in front of both, so it becomes 1. But if you had different numbers, say you had 3x to the 5th over 5x to the 5th, then this will become 3/5 to the horizontal asymptote. So that in mind, let's look through the problem. So for the first one, you have a 35 over x minus 5. Well, you see in the bottom, x has a power of 1 here, but in the numerator, you don't see an x. Well, technically, if you don't see an x, it technically becomes x to the 0 power, which is just 1. So now you see that the 0 is less than 1, so this horizontal asymptote value is 0. So this is not it. Let's do the second one. Second one here, y is equal to 5x. Well, this doesn't have a denominator, but it really is a denominator in this case of x to the 0. And x to the 0 is 1, and the power on top is 1 versus 0. That's why this is infinity. So for the third one, you might look at it and the sine x over x, you might recall that's like, oh, that looks familiar. I think that transfer and cancel out the 1. Well, then this case is 5 times 1, so it looks like the horizontal asymptote is 5. Actually, this is not the case. You can only use the sine x over x equals 1 rule when it's a limit of x approaching 0. Because we did not say that these graphs or these equations have to go towards 0, then we cannot use this relative identity of sine x over x. Now let's go to the last two. We see that we have 5x over 6 minus x. We know that the powers are the same. So far, so good. And in the top, the number in front of it is a 5. But on the bottom, the number in front of the 1 is a negative 1. So this is actually negative 5. So therefore, this also does not qualify. And of course, by process of deduction, but let's solve it anyway. We see at the top one, we have the highest power of 50x squared equal to 5. Whoops. So for this question, we're given g of x is equal to ln x over x, and they want to know what the max of g of x is. So solving this, we first have to recognize how do we get the max of the function, and then what value is it? So in this case, when we want the max of something, we actually want the y value. So we're going to solve for some y value of it. And to get the max, we first need to find the derivative and set it equal to 0. So then we need to find what g prime of x is. So g prime of x, in this case, is the quotient rule. So the derivative of the top of ln of x is just 1 over x times the bottom left alone minus the top left alone, which is ln of x, times the derivative of the bottom. The denominator of x is just 1, all divided by x squared. Now let's simplify things. This is equal to 1 over x is just 1, so 1 minus the ln of x all over x squared. And this has to be set equal to 0. So now we times both sides x by x squared to move it to the sides, times it by x squared times by x squared. The x squared cancels. That goes to 0. So now we're left with 1 minus ln of x is equal to 0. Move the should be equal sign. Move the ln of x to the other side. So then you have 1 is equal to ln of x. And then now solve for x, take e to both sides. And then on the right-hand side, the e and the ln's cancel out. Leaving me view x is just equal to e. And now that's what x is equal to, but that's not, they want the max value. So it's actually a y value that they're looking for. So let's take this and plug it back to our original equation. So original equation is equal to ln of x over x. And this time we're going to plug e in there. So then this becomes ln. Instead of x, we found x to be e divided by e. And then, of course, in numerator, we have ln and e together. They cancel out, leaving you with this 1. And the bottom denominator is just e, so the answer is just 1 over e. So for this problem, we're given f of x is equal to x squared times e to the kx. And they want to know for what value of k does g have a critical point at x is equal to 1. So looking at this problem, we see we have a critical point, and they want to know the value of k. So we have critical point only when the derivative function is equal to 0. So knowing that, we then have to take this f(x) function, we're going to take the derivative of it. So this has to become f prime of x. And of course, we take the derivative of this, it's going to be the product rule, which says take the derivative of the first one and leave the second one alone. So the derivative of the first one is just going to be 2x, leave the second one alone. It's going to be e to the kx. And then you add to that, this time you leave the first one alone, and you take the derivative of the second. So then leave the first one alone. It's going to be x squared times the derivative of e to the kx, just e to the kx, times the derivative of kx, which is just k. Okay. And now, to clean things up, I'm going to factor out this e to the kx because it's in both terms. So I'm going to pull that in front. So then I have e to the kx out in front. And what's left over now is just going to be the 2x plus k x squared. Okay. And now we need a critical point set equal at x equals 1. Well, the critical point only occurs when this is equal to 0. So let's solve for that, equal to 0. And we know what x equals 1. So first of all, when we set e to the kx is equal to 0 to solve for this k, this can never happen because e to a certain power can never be 0. It'll be a really small number, but can never equal 0. So this can't happen. Now we set the second part, which is 2x plus kx squared is equal to 0. And we said x is equal to 1. So let's plug in 1 in. So then now we have 2 times 1 plus k times 1 squared is equal to 0. This leaves us 2 plus 1k equal to 0. We move the 2 to the other side, and this gives us k is equal to -2. So for this question, we're given dy over dx is equal to 4 times the cosine of x. And we're given that in the initial condition, 4 of 3 pi over 2 is equal to 1. And they want to know what is the possible solution to y of x, or the general form. So basically, we need to turn y, dy or dx into just y. So we need to convert this into just the y form. To do that, of course, we have to take the integral of both sides. So then the integral, move the constant out in front. The integral of cosine is actually just sine, but don't forget it's sine of x plus a c constant. And that's what we need to figure out, what the c constant is. But luckily, they gave you the initial conditions. They said that when y was 1, we have for sine, the x value was 3 pi over 2, and then this is plus c. So now let's solve this out. So this is 1 is equal to 4. Now the sine of 3 pi over 2, or 270 degrees, is 0 plus c. Let's cancel out, then c is equal to 1. So therefore, the general or possible equation for y is equal to x is equal to 4 sine x plus 1. So for this question, we have 2y is equal to, 2y times dy dx is equal to 2x minus y. And they want to know what is d squared y over dx squared at 0.10. All right, so to solve this problem, we need to take the derivative of dy dx. Before we can do that, we have to move the dy to the other side. So then in the very first step, just algebraic cleanup. So dy dx is equal to 2x minus y over 2y, okay? And we need to take the derivative of this. So the derivative of this, of course, is just the quotient rule. But with the exception of that, whenever we take the derivative of y, we have to write dy dx. So now, taking the derivative of this becomes d squared y or dx squared is equal to, so the quotient rule, we take the derivative top. So it's just going to be just derivative of 2x is just 2 minus the derivative of y is just 1. But don't forget, we have to do 1 dy dx. And then we times that by the bottom, just as is, 2y. And then subtract that by, leave the top completely alone, 2x minus y. And then times by the derivative of the bottom, which is going to be 2 times the derivative of y is just 1. But then again, don't forget, the derivative of y becomes dy dx. And all of that is being divided by 2y, and all of that is being squared. Okay? So now we just plug things in. They gave us the 0.11, but they didn't give us dy dx. Well, no problem there. We just can solve, take our 0.11 here, plug it into dy dx, and we get the actual value for dy dx. So let's do that real quick. So doing this little side conversion here, let's put in the values for dy dx. So then you have equals 2 times x is 1 minus y is also 1 all over 2 times y is 1. So this becomes 2 times 2 is 1, 2 minus 1 is 1, so this becomes 1/2. So dy dx is 1/2, and then we have all the other values. So now we just plug everything in. So on the top, we have 2 minus 1 times 1/2, all times 2 times y is just 1. And then subtracted that, 2 times x is just 1, minus y is just 1, times 2 times 1 times 1/2. Oh, 1/2. And then all of that over 2 times 1 and all of that squared. So let's clean everything up. So over here we have 2 minus 1/2 is going to be 3/2. So you have 3/2 times 2 minus over here you have 2 times 2 times 1/2 all over. Down here you just have 2 squared. So then simplify the top, 3/2 times 2, that becomes 3, minus 2 times 2 times 1/2 is just 2. All over 2 squared is 4. So the answer is 1/4. Well, hopefully these videos have helped. If you have any suggestions how to make this video better, be it me talking faster, slower, or any other suggestions, please list in the comment below. Oh, and if you still need more help, and as I mentioned before, I do offer Zoom classes for the AP exam. Just actually put a comment saying that you need that, and I will reply with the necessary contact info. Thanks so much, and have a good day.